welcome to the stage. Now, Javier, since we were talking about space, let's launch in right away with you. So, how is the relationship between space and the semiconductor world changing?
Okay, the use of...
big question.
Yes, good questions. The use of semiconductor in space has changed a lot in the last years. Indeed, maybe 20 years ago, the type of semiconductors and chips that we used in space was totally different of the devices used at Earth applications. Indeed, we were using at that time obsolete devices that were not used at that moment in other applications. So this technology gap, has been narrowing during the last years, and I can say that now in that moment it's almost zero. Now we are currently evaluating some technology, for example, FPGAs like Versal with AI capabilities or NXP processors that are very close to the state-of-the-art solution in other applications. So I think that this gap has been almost reduced to zero. The entry of new players in space business like commercial actors like Google or Amazon in new constellation, new applications like Starlink or OneWeb constellation. This is accelerating this gap reduction because they are using these new technologies, and okay, they are pushing the rest of let's say classical industries in space to change the type of devices that we are using, and we are almost now at state-of-the-art status. The two main topics that are different in space chips compared with the Earth uses are radiation and dissipation, thermal dissipation. In thermal dissipation, the main constraint that we have is that these semiconductors are working on vacuum conditions, so there is no air for heat dissipation. So with the new chips that are becoming smaller and smaller, so we are concentrating high dissipation in a very small points, so it's making very difficult this heat dissipation. And I can say that I think in the short term, this will become the limit of the use on semiconductor on space, the heat dissipation, until we have new ways of having this heat dissipated with only convection and not only conduction and not convection on space. Only in radiation we have the problem of radiation in space, and okay, typically the main way of detecting this radiation problem in these chips was with power consumption, and now as this transistor are having each time a smaller power consumption, these problems produced by radiation, even transient or permanent problems of power dissipation, are more difficult to detect because they are producing very small power consumption increase, so it's becoming difficult to detect. So these are the two main constraints that we have in space for use of this new generation of semiconductors chips.
And other specific issues for the European Space Agency or space sector? Sorry, other.
Okay, we have at the European Space Agency we have the problem or the target to have this topic that we discussed briefly of European sovereignty, the capability of having technological solution at European level, also driven by this problem that we have some years ago with the supply chains problem of having enough chips to provide all the enough components for all the solution. So this is the main problem of or the main target of European Union and European Space Agencies to have this technological independence of Europe. So this is at mission level. There are main big programs to cover this, or to get this independence. We have Galileo in GNSS that is already ongoing. It's covering this equivalent to GPS in the US and other GNSS systems. In telecom, there will be this initiative of Fire Square program that hopefully will start and will be equivalent to some Starlink constellation in the US. Also in Copernicus New Generation for scientific mission, we will have this technology.
So thank you. Before we move on to talk about defense, I wondered if there are specific questions about space, and I think Michaela may already be wanting to ask.
Thank you. Yeah, great presentation. Yeah, I just wanted to mention and follow up on some of the topic that was brought up before about the option of maybe building, having the processing and building semiconductors in space that Charlie brought up. Yeah, it seems that there have been a lot of workshops in the past. And I think for space, for me, having worked on planetary missions for so long, is really important, of course, not only to have AI-enhanced chips, but I think the possibility, of having at least the option of people still looking at the possibility of having the facilities, right, in LEO, I think has a lot of benefits because there is no buoyancy or sedimentation, so that enables to have a product that at the end has less defects. So I think that's quite important, right? There is no convection. Also, we can think, most of these facilities on Earth that produce semiconductors, they basically have to produce or, somehow have high vacuum, right? And so we have to think that we already have that for free in space, right? So we have 10 to the minus 6, 10 to the, Pascal, and here on Earth, we are trying to get that, right? 10 to the minus 1 to 10 to the minus 6, to be able to do that. So I think that's a great advantage that we don't have to do that. I mean, I can go on for a long time, but I don't have time. But I think there are a lot of benefits also if we look at the supply chain, the way we manufacture that, right? We can use, of course, AI in many ways to for optimization of the process. And so I think it looks like, as Charlie mentioned, this hasn't gone anywhere. It looks like, and I'm glad to hear that there's a company in the UK. So I want to learn more about it. But I think we can do better at that. And I think if there's a way to de-risk this so that the companies, corporations can invest, I think that would be good. I think the problem I found is that there are very few studies on this topic. To be honest, there were some experiments, for example, by NASA astronaut Megan MacArthur, that she was growing crystals in space. And so there are maybe 160 studies for crystal growth, but not so much on the substrate. So there is still a lot that we can do, and so we need more data, right? I think for investors to think that this is a good idea. Also, I think there was a study and a collaboration between NASA and Intel that demonstrated that maybe you can even save up to $1 per chip, so that would mean millions of savings, billions. So I think it would be worth to exploring that more and maybe trying to build up the case, right, for industry to think more seriously about this.
So Javier.
Yes, okay. Yes.
Thoughts about that?
There are a few initiatives on that studies, very preliminary, I think. So there is a field to work on that and to advance. It has to develop several topics, not only this manufacturing process, but also, for example, launchers and how to have this production to the Earth again. So there are initiatives on that topic, also on data centers on space. That is also a topic that was mentioned before. Still very preliminary, and I think that it will be a field of investigation and investment in the future for sure.
So thank you, and let's
just wanted to mention one thing.
Okay, go ahead.
So I just wanted to say that, for example, to do these experiments, right, and to do the processing, we need hours, right? So the only way we can do some kind of microgravity on Earth or close to Earth, right, is these parabolic flights. So they last for a very short time. And so I think the only place where we can do it is the International Space Station, which is due, by 2030. So we have limited time unless we have other options. So that's just wanted to leave it there.
So thank you. I feel as if there's an ongoing conversation that's going to go on around space. But José Miguel, maybe we can move on and talk a little bit about defense. And there are some similar issues here about how the defense industry is perhaps changing its relationship with the semiconductor industry and driving change there. Could you address that for us?
Yes. Well, I was going to talk about the technology acceleration, that I think that it is an important trend in defense, and also about the geopolitical tensions. No? I think that these are the two main factors that drives the, let's say, the technology need and therefore the semiconductor need. No? But I would like also to add maybe also the problem of the threat. No? The threat is changing, is evolving, and just to put an example, we have talked about the underwater, the communications and the underwater infrastructures, and to protect that infrastructure is quite clear is a problem, and Europe is looking at this with a lot of attention. No? And this is something in which, for example, the photonic technology can support and can add new capabilities. Also in the space, no, to assure the use of the space is a critical factor. No, this is just examples, no, because there are so many threats that. But let's stress that to assure the use of the space, to assure the geolocation systems, the navigation systems, the secure use of the space with the surveillance and tracking systems, high-power radars that are able to detect any object at the space, also the space trash. No? So all that are examples of how it is evolving the situation and why appear new needs that also require new systems that also requires new technology. And photonics, high-power radio frequency amplifiers, as example, this is just examples as others that you have explained. No? But coming back to the technology acceleration and the defense activity is an activity in which everything has to be certified, everything has to be checked, everything has to be mature. Well, there is also attention to try to speed up the process of the use of the new technologies and the technology in a faster way inside of our systems. No? Obviously, on the platforms, on aircraft, planes, UAVs, whatever, we need smaller systems, more compact systems, SWaP-C, we say, no? Size, weight, and power, with lower cost. The C, very important for everything, and this is critical for the edge applications. No? And on the edge also we have to apply artificial intelligence to develop intelligence sensors and intelligent systems. And at the same time to develop a combat cloud, intelligent combat cloud, that it is able to combine all the elements on the scenario, multi-domain scenario, ground, land, sea, space, air, cyber, and we have to combine all together with space. We have to combine all together on that combat cloud and assure the communications. No? So there is an important trend there, the use of distributed systems, the use of communications. The semiconductors are critical on all that sensors and all that elements, but any kind of semiconductor. I mean, and that's from that point of view, it's very important to mix all that technologies together. The heterogeneous integration of elements is very important for this type of systems to provide more compact connections, the interconnection of the systems. I think that we have benefit from the advance in the civil use in the telecommunications, for example. The dual technologies, maybe defense was very important at the beginning of these technologies, but what we are doing now is to try to apply the existing technologies as much as possible and to cover specific areas that could be gaps that are not covered by the existing civil market. No? But the use of dual technologies is critical. It's very important because if not, it is very difficult to justify the volumes with the defense activity. So it is important to see in which areas we can use things that are already developed for other markets and try to use. No? That's very important. No? The acceleration need is also critical to assure the technological advantage of the defense. And this is now, I think that in the NATO and in many, and in the European defense, a focus on try to accelerate the application of the SMEs and the startups developments to try to check that everything is going faster. No?
Let me bring Daniel in here, because I think you can bring these two topics of space and defense together a little bit and talk about how small companies are driving some innovation and also driving some demands in those areas.
Yes, talking specifically about my company. And my company, we are not focused on one vertical. We are working in energy, medical, space, defense, many different markets, automotive. So one of the things, for example, they have talked about new technologies in the market, that it's getting a push to put them into space or defense, where they are more used to mature technologies. So companies like us that are working in other fields can bring those technologies, because they are common for us, and they can just see how they can be applied into these markets. Another important thing that, for example, we are doing, and probably is no surprise, looking that this is a semiconductor talk and everybody is talking about AI, is that we are just getting specialized in AI on the edge. So we are getting some partnerships with silicon manufacturers so that we can get access to the chips, to the training, to the software stacks, because it's not only the chip that you have to put there in the board, is that there is a whole software stack that you need to manage to be able to get the AI you have on your computer, but to the edge device. And something that we are seeing that there is really a strong growth on demand of these kind of solutions, or at least interest. Once people want to use LLMs, language models, on the devices. So there are applications. We don't see still a massive applications between our clients, but it's getting a push. And another thing that it's more interesting we are doing also is, since 2 years ago, we started into semiconductor design. It was something new for us, and we decided to go into that field to be able to support these specific niche markets. Because we consider that there are applications where you don't need a high-performance systems, maybe something that is low performance, high real time, specific for an application. But if you are able to provide a chip that is smaller, less power consumption, better to integrate, there is really a competitive advantage against, for example, a programmable device such an FPGA or a processor.
And we have a question already over here from Alejandro.
Yes, thank you. So Israel is, for example, one country where we can see that the government military forces have been able to become a promoter of the development of new technology and the cooperation with the small and medium companies, right? And the university. This is something which has allowed them to develop not only the defense system as a whole, but also a strong network of small companies and ecosystem as well in semiconductor. How far are we in Spain in order to be able to replicate this kind of example, which is also possible in other countries and has happened in other countries? And if we are not yet there, who would be the players that we would need to put into the table, into the same table, in order to be able to start replicating it? Thank you.
Well, you have mentioned Israel, that it is, let's say, well, the country with the largest percentage of engineers in the country. No, I mean, it is a very technical-oriented country, also very oriented from that dual use of the technology. You know, all of them have several weeks of service every year. No, so they know they are working on the operational field. They are working on the need, and obviously that knowledge provides a combination in which many things are provided by the particular case. No, so they know what is the purpose, they know what is the use, or they can let's say in a faster way to join the the military need and the military development with the civil development. No? So that come natural, and that's something that we have to do in Europe, for example, in a more, let's say, directed way, because, well, you know that until now, Europe has not been very aware about the defense capability, and it is clear that it has to be improved. What we can see, and that is related to the geopolitical problems that we can see, that there is a lack of capabilities in Europe if we want to have a balanced, let's say, sovereignty. I mean, it is not a question of being absolutely independent, but it is the question of being reasonably balanced with the rest of the allies, no? And we have to cover a number of gaps that are quite critical, no?
Let's take one more question, Andy.
Sure, thank
And
you.
then
I'm
we'll move
interested in the panel's views on defending against cyber attacks. So cyber is the new defense domain. Yes. The UK is actually the third most cyber attacked country in the world, I discovered not long ago, just behind the USA and Ukraine. And one recent cyber attack caused £2 billion worth of economic damage, so it's clearly on the front line of defence. And in relation to that question, are the panel considering memory-safe architectures such as the ARM Morello, which we think will protect against 70% of cyber attacks?
Yes, well, the cyber domain is other domain that could be related to what I said before. There are new threats. No? This is an example of another threat. And I think we are involved in several EDF programs, some of them led by Indra. And we are trying to, for sure, we are working on the development of that type of systems. And the evolution is to go into the agent-based AI systems to try to support that, because now when there is an attack, it takes long to analyze what has happened. It takes long to see what to do. We need much more responsive systems, faster systems, and the artificial intelligence, in this case the agent-based artificial intelligence, is very important to answer to that problem.
So thank you, all three. Thank you for great questions as well.